My name is Dami. I'm a freelance software engineer. I'm based in London and Kent. And when I'm not writing programs, I'm into fitness. I like mountain climbing, cycling, anything that allows me to move my body. You find me doing that. And I need to give a shout out to the organizers of this conference. They've done an amazing job, from Aisha to Tosin to Simi to Amdala Chooks, and everyone else. I want to say thank you for having me here, and I've had a lovely time. So let's get moving. So let's talk about software. So this is the state of software. When users use our software, this is what they see. They see the user interface, right? So they see either from a browser or from a mobile app. This is how they interact with our software. But as software engineers, we know this is not what our software really looks like, right? Especially when we're trying to discuss, to collaborate with our colleagues or pitch to a stakeholder, we tend to show something that looks like this, right? And this is how we think about software. We think logically, we think in terms of components and how they connect. And we think in terms of things like Flask and Celery and things like that. But also, we know that this is not the complete picture, and we're only lying to ourselves. And this is what our software really looks like. Do you agree with me? And when you're lucky, your software looks like what's on the left, right? It's clean and clear. You can see how different functions call other functions. But when you're so unlucky, especially when you have to work on a legacy code, your code looks like what's on the right. It becomes really like a tangled mess or a big ball of mud. And as you make changes to your code, it tends to look like this. Will you agree with me? So the red dots there are like potential bugs that crop into your code, right? So as the size of your software grows, the complexity increases, bugs get introduced. Sometimes when you release a new feature, you probably introduce 2 more bugs into your code, right? It's inevitable. It's bound to happen because sometimes you have communication breakdown with our team, or the requirement is not specified properly. A lot of things happen that, that makes bug crop into our code. Right? If you don't want bugs, just don't write code. Right? So let's do a show of hands here. How many of us like debugging? If you like debugging, can I see your hand up? Wow. No one likes to debug. So if you don't like bugs, if you don't like debugging, can I see your hands up? Interesting. Right. You see, bugs are actually fun. Have you heard of the saying, no pain, no gain before? Who's heard of that? Right? Bugs are painful, but it allows us to grow, right? So we need to embrace bug. But this is not to say bugs are good. Bugs are really bad. But we need to find a way around it. Because bugs actually cost money, right? Bugs cost a lot of money. So in 2002, software bugs cost the US economy about $59.9 billion. That's a lot of money. And in 2016, that jumped up to like $1.1 trillion US dollars. So that's the impact, that's the financial impact of bugs in our software. So the more you introduce bugs into your code, the more you are costing your company money, or you're costing your country our economy. In addition to money, bugs also waste time, right? So there's a statistics, there's a studies have shown that like it takes an experienced programmer about 1/20th the same of time that would take an inexperienced programmer to find the same set of defects in the code. Well, this means that people who are experienced, who know how to debug, spend less time trying to fix problems and trying to, and also releasing like bug-free code or applications that are not error-prone. And finally, one of the other things that you get from bugs is it kills productivity. You get really frustrated. If you have to like work on an application that's got a lot of bugs, and you have to keep, every time you release a new feature, you have to like deal with bugs and errors, what happens is that you have a very negative psychological state of mind. You don't find dealing with the application enjoyable anymore, and you could end up like this. You know, you then go to the gym trying to work out, why am I angry, why am I dark, and then, you know, hopefully you don't collapse on the floor. Now, that's not all doom and gloom. What can we do about it? So as software engineers, there's so many things we can do to make sure that we don't end up like this, and we remain happy. So I've been able to narrow that down into 3 things. So you can prevent bugs, find bugs, or fix them. And in this talk, I'll be talking about how to do these things effectively in Python. There's so many ways of preventing bugs in your code. But again, to keep it simple, because for lack of time, I've been able to reduce that into 3 things that I find most important, which is testing, logging, and error handling. And these 3 things, they ensure the quality. So testing ensures that your code is of good quality. And logging ensures that you have total visibility into your code. So as your code executes, logging allows you to understand what's going on, especially when there's a crash. You can understand the root cause of the crash, and you can have postmortem around your logs. And error handling is also a very great way to make sure that you can preempt the negative things that might occur in your code. And Python is equally great for that. So testing. How many of you actually write tests in your code? If you write tests, can you just raise up your hands and let me see? That's good. That's about like 1/3 of the crowd. But that's not good enough. Everyone should write tests, right? There's an argument around to do TDD or not. So TDD is test-driven development, which means every time you write a function, you write tests to test to test your function and to test the possible errors that might happen in your function before you actually write the function. And what that allows you to do is allows you to think about the design of the functions you're writing. And there's so many tests, there's so many ways to run tests in Python. So Python comes with a module called unit test, which just allows you to be able to run tests on a module or on a file or a class or a test method. If you're not happy with that, you can use notetest or pytest. And this is an example of a basic unit test in Python. So this is testing the string object. And if you can see clearly, I don't know how legible that is on the screen, but you can see there's 3 test methods there. One is testing if a string is uppercase, can be transformed from a lowercase to an uppercase. The other is testing if a string is upper, and the third one particularly is testing if an error is thrown when you try to run an invalid expression on the string object. And that should guide you in how to actually write tests. So not only should you test if your function works, but you should always test when your function doesn't work, and now that's handled in your code. Now, I've really simplified this. There's so many assertions you could throw in your code, and there's so many ways to test your code, but these 3 simple ways can guide you in how to make sure that your code is properly tested. And there is another module called coverage.py. What coverage.py allows you to do is it gives you a report on how extensive your test is, right? So it tells you if you're able to test all aspects of your code, and it gives you percentages and gives you goals that you have to work towards. The next way to prevent bugs in your code is through logging. So logging allows you to monitor the events in your code so that when it crashes, like I said earlier on, you can actually see the visibility on what happened or what data led to the crash. And There is verify methods in the login object that allows you to set the severity of your code. So you can set debug, warning, error, or exceptions. People tend to use prints. Especially inexperienced programmers tend to use prints in your code. But I'd advise you not to use print that much because print doesn't give you different levels of severity. Logs allows you to expand upon that. And there's so many other features that you can, so many other methods you can call on the logger object. And you can customize the logging facility in so many other ways as well. In addition to that, you can also use third-party services such as Logstash, etc., etc. So here is an example of running a command, running an expression, trying to divide 1 by 0, and then you get an exception. But the benefit of running login.exception is so that you can see the output of your traceback in your log file. So that's all well and good with logging. One other way you can log in a smarter way is to include the version info of your application in your log file. So for example, if you're running a microservices architecture, you have multiple services running, and when an error happens, sometimes it's very hard for you to find out which of the services is throwing up the errors. But with a pattern like this, it will be easier for you to see the Git hash in your code, and you'll be able to see the name of the service, for example, and that will allow you to drill down into where your code is coming from. Another way to achieve this is to use what is called the login adapter. So with login adapter, you can extend the login adapter class, and you can inject the context of your application in your log file. That way, when you're trying to debug, you don't spend too much time trying to find out what version of your application this error is coming from, and it also allows you to be able to reproduce your error quickly. So if you're running version A on the remote server, in your log file, you'll be able to see exactly what version you're running, and you'll be able to reproduce the bug on your local machine. So the third way to prevent bugs in your code is through error handling. So when you handle errors properly in your application, you actually prevent a lot of defects. And in Python, there's a class called exceptions in Python, right? And exceptions is a family of classes that describe specific kinds of errors. As you can see, it's an hierarchical structure. So at the top of the class is the exception class, and you have other kinds of exceptions like the arithmetic error, the assertion error, attribute error, and whatnot. And what this is it allows you to think logically about the different kinds of errors that might crop up in your code. And I'm going somewhere with this, because as you can see in the next slide, Django follows the similar tradition with exceptions. So in Django, for example, similar to the way Python works, you have the exception at the top, and you have other kinds of errors extending the exception class, but describes different kinds of possible errors, such as multiple objects returned when you're trying to get, multiple, for example, in Django, if you're trying to run .get on the ORM method, and you're expecting just one object, but you get multiple objects, that would throw up the multiple object return, for example. So you have a context to what was probably going on. So bear in mind, the whole idea behind debugging is to make sure that you can have a mental model of how your application works. So when there's a problem or there's a bug in your code, you don't have to waste too much time printing everywhere. You can just understand logically what the problem might be, right? And you can actually improve your intuition about your programs. So similarly to the way Django and Python organizes exceptions, it's always a very good thing for us to do exactly that in our custom application. So let's say you have an application that takes payments and also does social networking thingy, and you make a call to Twitter, and then there's a timeout. Rather than your program crashing, you can log the exception into your log files with something like Twitter timeout error. And so when you sit on your log file, you know exactly what's gone wrong. And if you're fortunate enough, you can actually find those errors in your testing phase or in your CI before your codes get into production. And I think finally on error handling, it's good to be assertive in your code. So in this sample snippet of code, we're trying to get something from Twitter. We get a result, but that result is a black box. You're not sure what it is. And there's a line here that says assertive instance result dict. So what happens is if your result is not a dictionary, an assertion error, which is another exception from Python, gets thrown. Now, an assertion error is very generic, right? You don't know what the problem is. What is it trying to assert? So what you do, you use the try except block to actually catch that error and then throw a more relevant error. So when you're in your log file, you know exactly what's wrong. So here is Twitter unexpected result error. So you know, okay, there's something wrong. Maybe Twitter's changed their API, and you can just quickly go into your code and change your code. But when you do something like this, what happens is you lose track of the previous assertion, previous error. So here, there are two errors here. The first one is the assertion error, but the second one that you've thrown is the Twitter unexpected result error. Sometimes you want to be able to have more visibility on the root cause. And in Python, there's something called the exception chaining. So with exception chaining, instead of you raising a custom error, you raise a custom error, but with a from statement. So what happens in your tracebacks is it gives you, instead of giving you one traceback, it gives you two tracebacks. So you can see that the Twitter unexpected error happened as a result of the assertion error, and you can also see the value of the dict possibly and the type of the object. So that's just briefly about exception and exception handling. And that is by no means exhaustive at all. You should go into the Python documentation or the Django documentation and check out read the documentation on the exception classes and how to better handle error. Speaking about debugging itself, we can't cover every aspect of debugging, but I'll try to talk specifically on the quick wins, what we can start using today to make sure that we don't introduce a lot of bugs in our code. So I'll quickly talk about code contracts. So how many of you have heard of code contracts here? Or is there any Java developer in the house or any .NET developers? So this is quite common in that sort of language. It's a way of enforcing your interface to ensure that your arguments, it's like typing, but not typing. It's like a step ahead of types. So what type enforcing does is that it checks if your value is of a specific type. But what code contract does is to have a sanity check on the value, so you can run functions on objects to see if they actually comply to a logic that you can specify in your decorator. So for example, in this sum function, we're checking if the parameter x is less than 10, right? So with typing, for example, you would be checking if x is an integer or a float, for example. But with this, we're taking it further by running an expression on your object to check for the validity of your arguments. So in a case where x is greater than 10, you get a precondition violation error, which is another exception. And you can extend that exception to provide context to your function, for example. If you go to this PEP document, you will find out more about code contracts. And this snippet is coming from a third-party library called Covenant. It's a Python third-party library. So you can go to this GitHub link to actually read more about that. So that's just a little bit about how to avoid bugs in your application. So the next interesting part of the talk would be on finding bugs. So when we are finding bugs, we don't want to be like this lady here. We don't want to be firefighting, right? We want to be more pragmatic. We want to be much more practical with finding bugs. So if you are the kinds who, so show of hands, how many of us use prints to debug here? So when you're trying to debug your code, you actually run prints to set the value of your code? So for people who don't use print, what else do you use when you don't use print? Can I get any answer? What? Sprint. So Sprint is still part of the print family. So has anyone heard about PDB here? Right, just two people, right? So for those who use print, I would advise to stop using print and to start using PDB. So the question is to print or to PDB, right? So PDB is a great debugger, right? Or how many people do people use debuggers at all here? For people who use IDEs to write code, right? So you probably use visual debuggers, like if you're coming from .NET or Java, right? If you're using Python, for example, Python has a visual debugger as well. So what a debugger does is it allows you to pause the execution of your code, right? So if you have a program, exactly, and you can step by step into that, right? So in comparison to using print, when you use print to try to find bugs, you find out that you're running your program multiple times. So you run a program once, you print, and you see the values of your program, and then you exit that, and then you run it again. And that's exactly what takes your time, right? That's exactly what takes your time, because you might spend the whole day trying to print and stop and start again, and it doesn't even give you a mental model of your application. But what a debugger allows you to do is you can step through it, and you can do a lot more. You can jump between various parts of your code to actually see what's going wrong. And I'll show you how to do that shortly. PDB is very, very extensible, so you can extend the functionality of PDB. And PDB is a standard library in Python, right? So without installing any third-party library, if you do import PDB.Assertive, I'll show you how to do that shortly. It's also customizable, and very flexible and very powerful. And the PDB shell looks like this. It gives you the list of commands that you can run when you get into the PDB shell. I'll show you an example of a file. This is a file called withdrawals.py, right? It's a simple program that allows you to withdraw your money from a fake bank, right? From bank of dad and mom. And here, as you can see, we have a line here called import PDB semicolon PDB.setTrace. Now the arrow is not quite pointing to where the line is, but it's just a line above the arrow. And when you run that, you get into a PDB shell. Now, similar to the Python shell. So in your terminal, when you run Python, you get into a Python shell, and then you can do all sorts of things in Python, right? So PDB is quite like that, right? Once you have that line in your code, it drops into a PDB shell, and when you run the L command, you can see the list of your code, the list of lines in your code that you're currently in. So how do I use PDB to debug in this context? So usually debuggers have breakpoints, right? So breakpoints are like bookmarks in your code. So if you have like 10 or 20 lines of code, you can set breakpoints at different lines, and what a debugger does is you can move to the bookmarks. So here, you run B is a command that stands for breakpoint. You run B18, and that tells you that you've set a breakpoint on that file, withdrawals.py, on line 18. And you're trying to find, look for a bug. And the bug is perhaps in line 18 somewhere. So then you press C. What that does is it plays your code, right? It plays your code and straight to the line 18 and stops there, right? And you can then run S, which steps into on line 18, for example. You have a function called undo withdrawal. That's where you think your bug might be. So when you press S, you get into the undo withdraw function, and there you run P. P allows you to print. So P is a shortcut for print. You do P balance, and you can see the balance the balance in the current function, which is an argument that you're trying to run an expression on, right? So what happens here is you've been able to move from withdraws.py into another module called handlers.py. And in handlers.py, you can see that there is no such dictionary named account details as was in withdraws.py. So when you try to print that, you get a name error, right, that says account details is not defined. So this is like what's just happened there is you've been able to use PDB to jump from one file to the other without exiting a shell. So remember I said earlier on, if you use print and your bug is in the handlers.py, what happens is you might put several print statements in your withdraws.py, you realize there's no bug in there, you exit, you check into handlers, and you can keep jumping from one file to the other. But with debugger, you can basically move through all your functions without even leaving your shell. And you can do so much things like trying to print the values or trying to run the function and get a result and trying to see where the problem might be. So with this, you can then press U to jump from the current frame into the previous frame, which basically means jumping from one module to another or jumping from one function call to the other. So after doing that, we can then print the account details and see that, oh, our account details is here, so the problem might be in this file. So that's just basically how to use PDB. I've been able to just narrow down into the functions that the commands that you use most often. So to move around in PDB, you use N, and N means just move to the next line in your code. When you use S command, you can move into the function on the next line. So as against moving to the next line, move into the function on the next line. B, as I mentioned earlier on, allows you to set breakpoints. So you can have bookmarks in your code. So when you're executing your code, it stops at the predefined break. So until is a command that allows your code to keep executing till it reaches the line greater than the current one. So what PDB allows you to do here is allows you to move around. You can move freely around, and you can be more comfortable with your code base. And in addition to moving around, you can also jump around. W means where. So at any point in PDB, you can see your stack trace. So you can see where you've been coming from and to where you are. So if you perchance run different functions to do different things, where would show you the stack trace, the stack trace. I've talked about U and D in the previous. I've shown you U and D in the previous slides. And then finally, introspect. So to introspect in PDB, you use P to print the value, PP to print the value. So if you're printing a dictionary, for example, it shows you clearly what the dictionary looks like. If you're in a function and you want to know what arguments have been passed into the function, you just run the A command and it will tell you the arguments. Now, L allows you to list the code that you're currently in. And LL also allows you to list the current function of frame that you're currently in. And when you pass an argument to LL, you can specify how many line numbers you want to see. Now, alias is another interesting feature of PDB. So if you look closely, I've been running commands like P, PP, A, and L. So alias, what alias does is similar to the way alias works in Unix, in your bash scripts. So for example, if you run Git commands, for example, and your Git commands are usually longer, you can create aliases to create shorter commands. So instead of running git pull origin, you could do GP, and you can just like a symlink. And in PDB as well, you can have aliases. So for example, if you find yourself like looping through dictionaries all the time or looping through tuples all the time, you can just have something like PI. I'll show you an example later on. You can have something like PI that will just do that for you. So you don't have to keep running Python expressions all the time. Again, this is a way of saving you a lot of time, right? So if you are under a deadline and you need to find bugs quickly and you have your aliases set up, you can save a lot of time while doing that. And the on-alias deletes the aliases. So previously I said PDB is very extensible. There's a Python library called EPDB, right? I don't know if everyone's heard of EPDB. EPDB stands for Extended PDB. Now, it takes PDB one step further. It's like PDB on steroids. So it allows you to do things like remote debugging. Say you have a bug in your server, and you find it very hard to reproduce that bug on your local machine. EPDB works with, it runs on Telnet protocol. So you can enable Telnet on your firewall, and then you can instrument your code in your remote server, and you can connect to that remote code from your local machine. And that way, again, you can save time. Instead of trying to figure out how do I reproduce this code on my machine, and you can just use EPDB, and you can just remote into the remote machine, drop into the PDB shell, and then move around your code and find what the problem is. Now, in addition to remote debugging, EPDB also does have additional features like store old history. So you can see the previous commands you've run in your PDB shell. You can restore old history. You can read the history. You can save the history. You can save your stack. So I talked about jumping and moving from stack. So all those movements, you can save them and share them with your team, for example, to do static analysis on your code. You can also mail stack. So with the PDB, all the movements I've shown earlier on, when you run mail stack with PDB, you can send that to an email, right? Especially when you do remote debugging, right? When you're in a remote session, you can use mail stack to email your stack trace from your remote machine to yourself. And that way you can possibly also reproduce your error on a local machine using mail stack. And then finally, you have complete. So that activates the auto-completion feature in EPDB. So when you're running a command, it can complete the rest for you. So you press tab, and then that's it. That saves you time as well. This is an example of, this is how you customize PDB. So this is a file called PDBRC. And if you have a file like this, I don't know how legible this is, but you can check out the slide later after the talk. With a file like this, you can activate, this is where you can activate your auto-completion, for example. There's a bunch of aliases here. So the first one prints a dictionary in a sorted dictionary. So if you see the line, instead of having to run this for loop all the time, you just do alias p underscore. So if you do alias p underscore with a dictionary, it prints the key and the values of the dictionary for you. And then you can also stack aliases. So for example, you can do alias pspi self. So that would print sort and then print the instance of the variable. So you can stack aliases as well. And you can run any valid Python expression in your .pdbrc file, right? So there's no limit to what you can do. Any valid command that you can run in a PDB shell, you can copy that into your PDBRC. So when you drop into the PDB shell, those expressions will be readily available for you in the PDB shell. So PDB is really very, very important tool, right? It's worth spending a week trying to get your head around how PDB works. It's going to save you time. You can extend it. You can make it work with Docker or with whatever tooling system you have, or whatever tools you have in your organization. Python comes with so many tools for debugging, and I would advise you spend a lot more time trying to learn how to use them. Now, other tools worth mentioning is the Django debug toolbar. For Django developers in the house, you must have used Django. How many Django developers are here? Woo! Go Django. Just two. How many Flask developers do we have? There seems to be more Flask developers in the house than Django, so I think Flask won. Right, so in addition to Django debug toolbar, there's Django shell as well. These are things that I don't think Flask have. Flask has got the wizard debugger, right? So that's a fantastic tool as well. So in your development environment, when you get an error, you can actually, similar to PDB, you can actually run expressions in your web browser if you're using Flask, if you use the Wizard debugger. Also, there's a Python module called code, right? So so for those who use print, there might be situations where you don't want to use a debugger or you just want to keep using print. If you're going to use print, I'd say you should use the code.interact as well. How that works is you can just run code.interact and pass the parameters in your file, and when you print that file, that drops you into a Python shell, right? Instead of a PDB shell, it drops you into a Python shell, and with that, you can then interact with all the objects in your code, right? So instead of having to print multiple times, code.interact will drop you into a shell. And also, there's another third-party tool called Sentry. So Sentry allows you to basically have visibility on the errors that happen in your code and the events that happen in your application. There's many other, finally, debugging tools that have security risk, right? So if you're going to do things like remote debugging, make sure that it's secured, and it's advisable not to do that in your production code, your production environment. Try to have your staging environments as closely as possible, your production environment, and use debuggers in your staging environment. And also try to use passwords or keys to have access into your remote environment. There have been cases where tools like the Wizard debugger was compromised, and people were able to have access into confidential data. So that's it about. So finally, the final one is once you've been able to find your code, you then fix it, right? So when you're trying to fix your code, try to write unit tests that covers the bugs that you found, right? So if you find a bug and you fix it, don't just fix it, write a test. Write a test case to cover that specific defect, right? So it doesn't happen anymore. Write a test and document that as well. Have an error reporting system, and so you can be accountable with your applications. And then you push. So that's it. Any questions?